Hello Internet. It's been a while since I've made one of these YouTube talking head type videos. I think the last one I did was in 2008 when I was first getting started with this whole internet atheism thing. I can't promise I'll make too many of these videos, but I would like to use some of the time I have right now to put just some of my thoughts online on just a couple different subjects. My goal is to hopefully be succinct and informative, while maybe providing something that isn't already out there. But let's be honest, this is the internet, so it's already probably been said somewhere. So to start this series, I thought I'd bring up a topic that bridges some cool physics with some classic skepticism. So let's talk fusion, hot and cold. Now I'm going to assume that you've already heard of the splitting the atom. This is a process where we throw a neutron at a giant atom like uranium and crack it like an egg. As the atom breaks apart, energy is released, as well as 3 extra neutrons which go flying off, splitting other uranium atoms. This process can get away from us with too much uranium, and then you have either an atom bomb or a nuclear meltdown like Chernobyl or Fukushima. Fusion, on the other hand, is the opposite process. It's what drives the sun and basically every star in the sky. If you collide 2 atoms together with enough force and under enough pressure, you can actually overcome the repulsive forces that push them apart and fuse them into a heavier atom. For example, 2 isotopes of hydrogen, deuterium and tritium, can be fused together to create a helium-4 atom. In the process, neutron is fired off with a lot of energy. In fact, fusion reactions release several times the power of fission reactions, which is why the H-bomb is so much more powerful than an A-bomb. Fusion is really hard to do though. It takes a lot of energy and pressure to force these atoms to fuse. The only place that it's reliably happening all of the time is at the core of the sun, where all of the gravitational energy of the giant star is compressing to force a continual reaction. To make fusion happen on Earth, we need incredibly high temperatures, millions of degrees, and intense pressures, which is why we call it hot fusion. Now, hot fusion is being worked on by a number of researchers around the world, using either lasers, magnets, or other techniques. Groups from Burnaby here in Vancouver to France are trying to develop the technology that would provide a potentially limitless supply of clean energy. Now, the skeptical angle of this comes in when we start to talk about cold fusion. In 1989, Stanley Pons and Martin Fleischmann claimed to have developed an excess of energy out of a device which electrolyzed heavy water onto palladium electrodes. Physicists and chemists, having no real theoretical framework to explain these incredible results, were justly skeptical. And when efforts to duplicate these experiments ultimately failed, all but a few fringe supporters abandoned the project. In a curious twist on this story, during the Republican primaries in 2011, Mitt Romney was asked about renewable energies, to which he replied in part, quote, "I believe in laboratories, looking at ways to conduct electricity with cold fusion, if we can come up with it. It was the University of Utah that solved that. We somehow can't figure out how to duplicate it." It turns out that Pons and Fleischmann were working at the University of Utah, and when they applied to the U.S. Department of Energy for funding, their proposal was turned over to Brigham Young University for peer review, which is the center of the Mormon higher education system in the heart of Utah. So perhaps cold fusion was just a Mormon plot. Nevertheless, the quest for clean, renewable energy continues. For now, the cliche remains true: fusion is always 50 years away.